today is solar, wind, and hydrogen. Welcome to the greenest EPIC online meeting to date. Welcome to Photonics for green energy generation.
The actual economic and death toll from climate change will be much, much, much greater than what we have with this pandemic.
Our vision for a climate neutral continent in 2050 is kind of 50 actions for 2050.
The whole world is talking about it. EPIC needs to talk about it too. On March 1st, EPIC goes green. In fact, Photonics already plays a role in 3 important areas for the transition to renewable energy generation. Hydrogen fuel cells, wind and wave turbines, and solar panels are key to achieving an affordable, clean, and prosperous economy. Let's start with hydrogen fuel cells. They are becoming an alternative to batteries, empowering consumer electronic devices as well as residential and industrial power generation. Hydrogen fuel cells are currently one of the cleanest sources of energy with zero environmental impact either in production or recycling. Remember that their bioproducts are simply heat and water. That's where fiber lasers excel in welding very thin layers of stainless steel with low distortion and zero leakage. Our EPIC member TRUMPF in Germany, especially after the acquisition of SPI lasers in the UK, have positioned themselves as one of the leading system integrators enabling such welding process, together with our EPIC member Prima Power in Italy. But there are challenges that we still need to discuss, so let's ask them the EPIC question. Photonics is also playing an important role in keeping expensive wind turbines safe and efficient. Thanks to companies like Technovis, Optics 11, or HBK Fiber Sensing, we've known for years that Photonics fiber sensors are important to monitor blade failure. But now, ground-based LiDAR is helping to design more effective wind farms before anything is constructed offshore. And once the wind turbine is in position, LiDAR can optimize the rotor speed and also spot and correct for yaw misalignment to get the maximum energy when the wind blows. We should ask the EPIC question to companies like Windar Photonics or Zacek LiDARs to learn more. But maybe LiDAR can impact the design of smarter tidal wave projects powered by the moon. And talking of the sky, we can't leave solar out of this. Sadly, we do not have any major production of generic solar panels in Europe anymore. But now, this can change. There is a new solar revolution, bringing solar cells everywhere. Solar powered windows, solar drones, solar biosensors, they all have something in common: the need for customization. And that's where Europe excels. Pilot lines for solar cell production, like Hanwha Q cells in Germany or ST Microelectronics in Italy, will ensure that the next solar revolution is powered by European manufacturing capabilities. In short, there is plenty to discuss, so let's connect Photonics for a greener, safer world on March 1st at 3 p.m. Sign up for the Zoom room or watch live or later at the EPIC YouTube channel. I don't need coffee. Photonics gives me all the energy I need. And just in case, I drank a lot of coffee for this meeting to make sure that we don't have any lack of energy. I know that you are almost as excited as this particular topic. In our opinion, this is going to bring a lot of potential collaborations, and we're also aware of the Horizon Europe program and the call for green energy. I'm going to talk about later, because I think there is opportunities also for getting funding for this particular working group that we have today. As I said, today EPIC goes green. And EPIC also goes green. I'm super happy because now we are almost there with 700 members. Francesca, I think we are 698. Welcome AT&S to the EPIC consortium. EPIC is just an association of almost 700 companies, but we have 15 people full-time, 15 people full-time, and our job and our passion and our energies is to make sure that we organize very focused events to get people to work together, that we actually provide access to a large network, that we help companies raise money, we help raise investment, that we have the biggest website to find a job in Photonics, jobsinphotonics.com, and also that we provide to all our members market reports. We buy them commercially, we give them to you for free to make sure you use them for your strategy. Today, we are almost at the end of the 3rd season of online technology meetings. The topic for the 4th season are going to be announced later on, spoiler alert. But today we are talking about green energy generation. But for those of you, I would like for you to pay some attention to some upcoming meetings. In 2 weeks, we have LiDAR 2.1, which I think is very interesting for some of the companies in the room. And in 3 weeks, pay very good attention to this one. We do have an event targeting sustainable textiles, wearable fashion, and design, also attracting end users from that particular market segment. And you also know this, but I will remind you, this year, for the very first time, we are supporting also the quantum industry. We had already 2 fantastic quantum meetings, especially the one last Friday on defense. In 2 weeks, next week on Friday, we do have a meeting on quantum technologies for the medical market. This is shaping up also to be fantastic. But today is green energy. And first of all, I would like to acknowledge the fantastic support of our media partners, Electro Optics and AZO Optics. Thank you so much for being the voice of everything that we are doing here. And also, nobody in the world can do anything great alone anymore. Today, we're joining forces with Joint Forces for Solar. Later on, you're going to hear from Parag Bhamre from EuPD Research on what this means to join forces for solar. But before that, I need to give the floor to Carissima Francesca Moglia. Dr. Moglia, what's in the menu today?
Thanks a lot, Jose, for your introduction. So as you might have seen already, this is our agenda for today, but this is a bit the boring version of the agenda. That's why we have a much nicer one. That's the one. So it's basically all of you here, all of you that sign up to be here today, addressing all these fantastic topics towards green energy. So as usual, we try to contact it and to engage end users of the topics. So like photovoltaics, wind and hydrogen, maybe we will hear from them for sure some opinions and also a talk about it, so about the photovoltaics part. But then, of course, it's important for us to engage the full value chain of these topics. So that's why we have many system integrators, for example, also towards the wind and using LiDAR, but of course, many laser manufacturers also towards the different application for the 3-4, let's say, application towards green energy. But then, of course, also cameras and detectors. We have a lot of our association, of course, and together with the Joint Solar Forces for Solar is here, so, and many others, so hydrogen association, because that's the interest really behind it. And then, of course, the full manufacturing also and a supply chain towards the lasers, basically, and system engineering, but also semiconductor manufacturing. And last but not least, R&D, that is always more important, and for the future of what is the technology doing for green energy production in the future. And now I give back to Jose.
Thank you so much, Francesca, and congratulations for all the hard work you've put bringing the end user system integrators in contact with the members of EPIC. Today is being particularly challenging, and you managed to excel on the task. Congratulations, great job. This slide only represents the companies who registered for this meeting. So if you're an EPIC member, you're missing the logo on this slide. That only means that you forgot to register. Don't let it happen again. We didn't forget about you. We never do. You just forgot to register. And also, let me remind everyone that this meeting is also broadcasted in YouTube. So hello, YouTubers. Thank you very much for joining today. If you have any question during the meeting, please write so in the chat, and I will be more than happy to read it in the room. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I will formulate the introduction. And of course, this is also valid for the people here in the Zoom room. Use the internal chat during the meeting and do business. This meeting is about business, so please use it to generate leads and potential cooperations. If after the meeting you didn't manage to talk to the person that you wanted, send me an email and I will make the introduction. The participant list of companies registered is public. You have access to it. Please make sure you use it to the best of your advantage. Let's get the meeting started. I can't wait for this. As I said during the introduction, nobody can do anything great alone anymore. For this meeting, we join forces with Joint Forces for Solar. And to hear what that means, we had one of the top consultancy firms worldwide in the field of green energy, EuPD Research. Parag is here with us to tell us what means to join forces for solar. Thank you very much, Parag, for being with us today. The floor and the attention of everyone, we are worldwide today, goes to you.
Thank you, Jose. And thank you, Francesca, for that energetic introduction. Really appreciate you having me here. And to a good afternoon to the entire audience. I hope you are all having a great day. And I hope to add some thought from the PV industry to this entire presentation. And today I would like to take this opportunity to present an overview on the global photovoltaic market and just provide you some insights as to how this particular industry has developed over the last years. I'll just go ahead and share my screen.
Yes, please do so.
If you can confirm, Jose, if you can see my screen.
Crystal clear.
Yes?
Yes.
All right, perfect. Yeah, so good afternoon to everyone. My name is Parag Bhamre, and I am a partner at EuPD Research. So before I jump into my presentation, I would like to take a minute or two to talk about EuPD Research. EuPD Research is actually a market research and a consulting company. We are headquartered in Bonn, in Germany. I myself am based in Dubai. So it's slightly evening time here, but still full of energy. And well, our company has been in business for about 20 years, and we conduct a lot of market research and consulting projects in the renewable energy space. And our focus over the last 20 years or so has been photovoltaics and storage. So what we essentially do is we conduct a lot of market research, we publish reports from time to time, and we also conduct a lot of exclusive projects related to the markets with various customers globally. We also provide certain certification services for the PV industry, and some of the certifications or the seals that we use are extremely popular within the PV industry as such. From time to time, we conduct a lot of surveys within the markets. So we are trying to talk to a lot of system integrators, to end customers, to understand what their requirements are and what kind of applications might fit their requirements. And we publish several reports from time to time. My colleagues at Joint Forces for Solar, their endeavor is to bring together the entire photovoltaic industry together. And we also do conduct a whole lot of events from time to time. Now, having given this short introduction, I wanted to jump into my presentation right away and talk a little bit about first the renewable energy and how we think the photovoltaic industry will develop over the next years. When we look at the renewable energy industry, since 2010, solar and wind have both seen a rapid rise in terms of installations. So back in 2010, the total global installed capacity, which is the renewable installed capacity, was approximately 1,200 gigawatts. This, over the last 10 years, has almost doubled to more than 2,500 gigawatts across the world. And the two major contributors, or the two major technologies which contributed to this particular growth, have been wind energy and solar. And within solar, particularly, it has been the photovoltaic industry which has made giant leaps. Now, when we look at the installed PV capacity globally, like I mentioned, over the last 10 years or so, we've seen rapid growth. But particularly in the last 10 years, 4 years or so, we've seen the entire installed capacity grow at a CAGR of 25% plus. And every year, the world is adding more than 100 gigawatts of capacity year on year. So this has been a consistent trend since the year 2016. We expect that 2021 onwards, this growth will even increase further as the costs of solar go down. Now, when we look at this particular growth, this growth can be attributed to three major reasons. The first major reason is globally, all the governments across the globe are really promoting renewable energy and in particular solar. So there are strong support mechanisms in place to promote the growth of solar photovoltaics. On the production side of things, we've seen a lot of economies of scale, and be it module manufacturing or inverter manufacturing, which are the two major components within the solar system, we've seen that the total capacity, the production capacity, has increased tremendously over the last years. This has really led to reduced costs. And the next couple of slides, I will talk about these economies of scale and how you will see the production has increased over the last years. And third, and the most important reason, is that there have been tremendous technological improvements within the solar sector as such. And this has really led and this is the reason why you see the growth has been more than 100 gigawatts year on year over the last 4 years. When we look at the top markets across the world, 2020 was a difficult year for a lot of sectors all over the globe because of the COVID-19 pandemic. But solar photovoltaics continued to grow despite of the pandemic, despite of the lockdowns. And there were some large-scale solar projects which were delayed and the deadlines were extended. But overall, if you see, the market kept growing, and only in the year 2020, we saw approximately 125 gigawatts of installed capacity across the globe. Now, to put these things in perspective, or to put these numbers in perspective, roughly speaking, 125 gigawatts actually translate to approximately 416 million solar panels being installed all over the world. So that's really a huge number. So there is production capacity, and the demand has been tremendous over the year, despite of the pandemic. And to name some of these markets, when we look at the PV market in China, that has been massive in the year 2020. United States also installed approximately 19 gigawatts in 2020. And Vietnam also saw a tremendous growth in the year 2020, amounting to approximately 10.5 gigawatts being installed just in that particular year. Coming to Europe, Europe saw a tremendous year again in 2020. A total installed capacity of approximately 18.2 gigawatts. This was the second best year when it came to solar installations in Europe. We expect that this trend will continue in the year 2021 and 2022 as well. To name some of the markets which were very important within the European markets were Germany, with a total installed capacity of 4.9 gigawatts in 2020, followed by Spain, which installed around 3.2 gigawatts, Netherlands and Poland rounding up the top 4 markets within Europe. Now, when we look at so that was the demand side. When we look at the manufacturing capacities, there are a lot of tier 1 module manufacturers which have very ambitious plans to scale up production. A lot of them are in China, but there have been several production initiatives also in Europe, which have started to take place. When we talk about the top 10 PV module manufacturers, they actually accounted for almost 80% of the production capacity. So vis-a-vis the 125 gigawatts which were installed in the year 2020, the world saw a total production capacity, available production capacity of 165 gigawatts. In the year 2021, we expect that the total global demand for solar photovoltaics will actually increase to between 150 to 170 gigawatts. So in order to cater to this particular demand, there are a lot of production activities which are going on in China. And like I mentioned, there are several manufacturers within Europe which are also planning to start up new production lines. And we see demand definitely keeping in pace with the production activities across the globe. And talking about the module technologies, we've seen a tremendous growth when it comes to the technology itself, how it has progressed since the year 2010. One of the key metrics in the solar PV modules are basically the efficiency level of these solar panels. It is basically the ability of a solar module to convert incident solar light into electrical energy per unit area. This number from 2010 has increased from 14.7% to more than 19% in 2019. Today, we are talking about efficiency levels of 21 and 22%. These are already commercially viable, and these solar panels are now available in the market. We have also seen that the output of these solar panels over a period of time have increased tremendously. So there were times when in the between 2010 and 2016, where we used to have solar panels which were approximately 250 watts or so. Now these panels have a power rating of 400 and even 500 watt peak plus. This has primarily been possible due to increased wafer sizes, and the increased wafer sizes are today becoming a norm in our industry. With increased wafer sizes and power ratings of these solar panels, the overall cost of installing a solar power system has really gone down. So all the other kind of equipment that you need to set up a solar power plant has gone down, with reduced cables, requirement for cables, reduced structures, and so on. This has really made solar one of the most low-cost energy production technologies across the globe, even vis-a-vis compared to coal. When we talk about the module technologies, the industry has completely moved towards PERC technology, which is passive emitter rear cell technology. There are several module manufacturers who are now trying out the HJT, the heterojunction technology, and also IBC, which is interdigitated back contact technology based applications. So we've seen this complete shift happen over the last decade or so. Also, we've seen a trend where the entire migration from multicrystalline to monocrystalline is almost complete. Now, the entire PV industry is working on the monocrystalline technology. This is another trend that we have seen. And what we have also noticed is that a number of the solar manufacturers or the module manufacturers are developing the solar panels based on the applications. So, for example, companies are developing highly aesthetically pleasing, lightweight, high efficiency solar panels for the residential segment. So anything that goes on a rooftop or a residential rooftop, they are quite aesthetically pleasing, lightweight, and very high efficiency solar panels. Within the commercial and industrial segment and the utility scale segment, we are seeing companies use bifacial solar panels, half-cut cells, and glass, so which allows increased production due to reflection or a certain albedo from the sunshine that you get, or the reflection from the ground. So this is in order to increase the total generation from a solar power plant. So a lot of development has been happening from a technological standpoint. And like I mentioned, due to the economies of scale, the PV module prices have also dropped significantly over the last years. Just over the last couple of years, the module prices have gone down approximately 33%. And if you were to take a complete timeline from starting 2010 till 2020, the overall costs for solar have gone down in the range of 80 to 90% of what they were back in 2010. Based on all of this, we definitely think that solar as a technology, or solar photovoltaics as a technology, has a very, very bright future. Now, owing to improvement in technology, the economies of scale, and definitely the support of the various governments all over the globe. And with this, I would just like to end my short presentation if you have any questions, I'd be more than happy to take them.
Thanks a lot, Parag, for your contribution. Thanks a lot. So usually we ask the epic question to every speaker. So what can you do for them and what can they do for you? Let's say you are more giving a market data, but let's say, what do you think that the photonics world, how can it support actually this, for example, further improve of efficiency in solar cells development, or also the decreases in cost that you just showed that happened so far? Where do you think that is maybe the part also in the production where photonics could help?
So, I mean, from a production side of things, there are several places where the efficiencies can be brought along. Definitely, I think the types of cells which are being manufactured today, they, depending on the application, I think it's extremely important to look at the segment that the panels are being produced for. So for example, the photonics industry. So when we look at the residential segment, there is a lot of need for building integrated photovoltaics. So this is an area which I feel that the photonics industry can really contribute to, because as we look at the overall efficiencies within the BIPV segment, they are low. And a lot of focus right now within the PV industry is on the commercial and the industrial or the utility scale segment. So I think a lot of contribution can be made within the BIPV segment. So that's one thing that I can think of at the top of my head. But yeah, I'd be more than happy to share some ideas and thoughts with the others.
Actually, we have Igor later that will talk about actually this, so integrating even in a very designable way how this can be done. So maybe Igor, you want to already mention this? Is it a very appealing topic for you? If you want to comment already now, please.
Yes, we definitely see the great market need for kind of like solar modules which are aesthetically pleasing, especially in an urban application. Well, frankly speaking, I have a whole presentation about it, so let's not jump.
So Igor confirms. That's let's say we made a loud nodding. So now, Igor. So thanks a lot. Now maybe we go a bit more to the supply chain. So people that are working behind the solar cells production. So we have Clark Lee here from Relays, and maybe you can introduce yourself a bit, tell your role in the photovoltaics industry, and say a bit a comment about how actually photonics can contribute, and you see your vision for the future.
Can you hear me?
Loud and clear.
Hi everyone. My name is Clark. I'm in charge of the sales. I'm a sales director for Asia market for Relays company. We are specialized in the laser scanning solution for high speed material processing. So recently we involved a lot of a project for laser scribing, for example, laser contact opening, and laser dope selective emitter. These two laser processing projects, and I want to ask, what do you think about for the future? Will this production of PV cell happen in Europe, or still contribute mainly in Asia?
So if I may take that question.
Absolutely. I guess it was to you. You are the
perfect
expert.
So I do believe that, yes, there is a huge production capacity which is available in Asia. But, due to the COVID pandemic, I think there has been some sort of a rethought in terms of, how much production capacity should be just available in one country. There is a initiative actually within Europe to increase the cell manufacturing capacity and the PV module manufacturing capacity. Some initiatives have been taken. So there are companies such as Meyer Burger, some very local companies within Germany, for example, Heckert Solar, AE Solar, they are manufacturing within Europe. So I think this will be a split between production in Asia. So like I said, due to the COVID-19 pandemic, we saw a lot of logistical problems to get all the solar panels into Europe or other global markets. So I think there will be some decentralization when it comes to production capacities, although a majority of it will continue to happen in China. But there are definitely efforts to ramp up production capacities within Europe. It essentially boils down to costs and the economies of scale.
Thanks a lot for these answers. So thanks a lot also, Clark, to introduce yourself and a bit explaining your experience in this market. Now I would say it's time to go to someone that I was told is a photonics expert, now sold to the energy sector. So it's a real pleasure to introduce you, Andrea from Enel Green Power, that will have the next talk in the agenda. So Andrea, if you're there, do you hear us? Yes, very good.
You hear us? Okay, sorry
Yeah,
for
we
the
hear
mask, but
you, of course.
I am in the office and there are other people.
No problem. We very well know this issue in the last months. So
Okay.
please, the floor is yours so you can share your slides directly. Thank you.
Yes, okay, just where is the share
Is the
button?
bottom below? There's a green button.
Condividi, yes, I found.
Yeah.
Okay.
And then we see if you get the right screen. No problem if we get some.
Yes, here we are. Okay. Here the presentation. Okay, it's here.
You have to choose the screen, otherwise we don't see anything yet.
Yes. Do you share?
Yes, now something is coming.
Okay.
Yes, if you go to presentation mode, because now,
Perfect.
Okay, you have two slides. Okay, okay, this is the wrong screen. So either you switch.
The other one.
Yeah, exactly.
Yes, sorry.
No problem. You can go in impostazioni di visualizzazione and switch.
Okay.
Yes, there you go.
The one. Okay.
Yeah, very good. The floor is yours.
Okay, I'm Andrea Canino. I'm responsible of the Solar Innovation Lab that Enel Green Power has in Catania. I will be very brief just to introduce the company and the challenges that we have in mind about the possibilities that the photonics can have in solar field. Enel Green Power is an utility company. We have as you can see, almost 50 gigawatt totally capacity, not only solar capacity, but we have several different renewable energies installation worldwide. We are spacing from hydro to solar to wind and to geo energy. And in our vision, our expansion in the future will reach 145 gigawatt. So we expect that for the future, the solar energy will be one of the most used installation worldwide. We are spread all over the world, so we have interest in more than 28 countries, and we have a lot of plans. From our point of view, the photonics can have an important role. Consider that the photovoltaic market is essentially a low-cost market, so the revenues are very low. So the important is, from our point of view, to be able to control very well the production and the quality of these photovoltaic modules, especially once you have them on the field. So once everything is installed, the idea is to develop instruments that can be used for the control on the field of the photovoltaic modules. In my mind, there is the basic, one of the basic instruments that can be the photoluminescence. but actually photoluminescence tool to work on the field are quite at the moment. I think that there are no tool to do something like that. It's quite complicated because you need a very coherent light. You have to have a sensor. You need to have several different part of a complex instrument, let me say. But I think that it's something that it's possible to develop to be used on the field like control tool of quality. Consider that the standard control that we do, it's electroluminescence. Electroluminescence is easier because you are pumping by using electricity. In photoluminescence, you can evidence different kind of defects. So from our point of view, could be very interesting to have some tool developed with these characteristics. Another very interesting tool could be something related to the easy measure of reflectivity, transmittance, soiling directly on modules, something that can be easy to use. That can be used also from a simple operator, just to monitor the characteristic that the modules have in time, year by year on the field. So it's another point that can be developed and can be very interesting. After that, I thought about the possibility to develop optical sensor for the monitoring of temperature and other physical parameters. For example, let me say some modules have a specific characteristic that are bifacial, so they can catch the light from the front and from the back. So to have something that maybe can be integrated on board the module can be very interesting, because you can monitor the characteristic of the transmittance of the module, for example, in situ, directly on the module itself. Let me say it could be a next generation of photovoltaic modules that can be a smart photovoltaic modules. I know that there are several suppliers that are starting to work, for example, to intelligent junction box. But on the other hand, it's possible to think to several different applications for very small and smart sensor like this that can be integrated on the modules. There are other several possibilities that we can discuss about, but I think that these three areas are the main areas where we can move for further development of optics applied to photovoltaics. Thank you for your attention.
Thank you, Andrea. Thanks a lot. So it's true that you had a wish list, because that's exactly what we ask. What we ask our speakers. So to say, what is your wish list? So we had it. So now we can maybe unshare your screen.
Yes.
Yeah. So let's go here. Yeah, very good. So now you heard all in the room what is needed. So very coherent light sources, very precise detectors. I mean, I guess we can actually do more than what Andrea is thinking. So maybe I would like, if you are shy and nobody wants to comment, I would go to NIT, so to Martin. From the detector side, I believe he has a couple of things to tell us. Right, Martin?
Yes. Hello. Thank you very much. You can hear me fine?
Loud and clear.
Yes.
Very good.
Perfect. Very nice to meet you. So yes, NIT, we design and manufacture shortwave infrared sensor and cameras. And you mentioned electroluminescence and photoluminescence inspection for solar panel in the field. So my question is, do you think this sensor can answer to your need? What type of, exactly what resolution are you needed?
Okay, actually, there are already applications with this kind of, for example, by using drones with the cameras and so on. The difficulty is that usually these applications are is used for a global monitoring of the solar field. So there is the drone that is passing, watching a lot of modules and so on. On the other side, what I think it's important is to go, for example, to understand why a single module is not working. So the idea is, from my side, it's to the possibility to develop something with a very high resolution. I was thinking below 50 micron. Working on a single module. For example, let me say a single a tool that can be applied only on over a single module, something like a scanning tool or something like that. Because the understanding of the root cause of the failure of the of a module can enable the maintenance, let me say, the predictive maintenance activity on all the other modules. So the general control can be done by using a drone flying over all the field, but the punctual control must be done with something that is more precise, without unmounting the module and bringing them in the laboratory on the other side of the world. Consider it's something like that. So the intermediate application could be very, very interesting.
Okay, I understand. Good.
So now maybe from the more the laser side, so the more for the coherent source, maybe Yoshiaki from Sumitomo, do you have something in mind, some integration? What is the interest of being in this meeting today? Can you maybe comment on this?
Hello. Can you hear me?
Yes, we can.
Actually, we Sumitomo Electric are not only a semiconductor optical devices company, but also environmental and energy solution company. And I would like to know what Photonics can do on environmental and energy clusters. That's why I'm here.
Very good. So that is the right way to be, so the right place to be. So that's why we are here today. So Andrea, do you want to maybe give a final remark on what exactly, so what is the timeline? So is it something, your demand you are talking about now is mostly something that you would need kind of immediately, right? But is there something that you can foresee that can be needed maybe in 1 or 2 years, when exactly the deployment will be even larger, so maintenance will be even more important, so that the lifetime of the panels have to be the longest possible to be efficient? Or other technology that you foresee could help in the future, and that maybe now is too early to have them really off the shelf?
Okay, from our point of view, consider that the interest in the tool that can allow to enhance the capability of a predictive maintenance start to be very, very important, because of course, if you can do an action before to have a drastic failure all over the field, it's quite important. So to have tools that can allow to recognize the problems as soon as it's possible, it's a must. The efficiency, the global efficiency of the solar field for the following years will be very, very important, because consider that the incremental gain that we have, it's starting to be very, very small. So the best we can do for the future will allow to have a little gain, unless we will change completely the technology. So from our point of view, solution should be ready from in 1 year, at least 2 years, to be applied as a commercial available tool in the field.
Understood. So, and then of course, if there are other technology coming, who knows, then we will move to this. But for now, I understand so that we have to be fast to be able to keep the efficiency and the conveniency of such tools. So very good. So now, if there is no other comments or questions, we could move on and go to TRUMPF. So Johannes, I see you're in the room, right? And we are talking now. There you go. Thanks a lot for joining us today. So if you want to share your screen, the floor is yours towards a bit more high power than for sensing, I assume. This will be the topic of it. Well, TRUMPF is involved. We are talking about some other applications more on batteries. So the floor is yours.
Can you see my screen? Can you hear me?
Not yet. So we can hear you, but you have to go to the green button on the bottom of the screen and then choose the screen. If you don't choose, we still don't see it.
Okay.
Yes, something is coming now.
So.
Yes, if you go to presentation mode, perfect. The floor is yours.
Good, thank you. Thank you all for joining me. I'm a little bit a last minute presentator here. So what I would like to show you is a bit the impact of laser technology in the lithium ion battery manufacturing. So I think it's a interesting topic where photonics, where lasers play a major role. And just to start from TRUMPF point of view, how we divided the topic e-mobility and battery for us. So we look on battery cell and modules, and here there's, let's say, the biggest share of laser potential hidden in this section. Then of course it's electric drive, let's say e-motors, interesting laser applications, electronics and power electronics for batteries. Something in battery pack and frame, and of course, as a future topic, it's also fuel cell. Usually I start with a joke, but I'm not really good in joke telling. So I just want to make you think a little bit. And a smart guy has developed once, let's say, the pyramid of basic human needs. And I just dared to extend, let's say, our basic human needs, and I hope this guy would excuse me that I just dare to extend this pyramid. And I think in our daily life it almost belongs to our basic human needs that we have Wi-Fi. We probably wouldn't have our meeting today here. And of course, batteries. Batteries are in our life all over, and even if we don't know this, there is no way to get around batteries. And I think we all agree that we have to make these batteries greener and better and more efficient. If we look on the mobility sector and automotive, maybe a little bit earlier now with the current development, but we assume that in the year 2029, there's about half of all cars on the streets are electrified in some kind of, let's say, electrification. There's, of course, pure electric cars. There's hybrid cars, plug-in hybrid, mild hybrid. And of course, let's say the combustion engine will accompany us now for the coming years as well. So what are the challenges? What are the challenges for e-mobility and for, let's say, the battery manufacturer when we think about electrification of cars? Of course, batteries, they have to be more, they have to have a higher density because everybody wants to have a higher mileage. They need to be charged very fast. Otherwise, we will not accept because we're used to fill up our gas tank in 5 minutes or less. And I thought where the laser helps to make batteries, let's say, better and more efficient. And I divided it in, let's say, on the battery cell level, on the battery module level, on the battery pack level. And where you see this red laser spots here in the text, this is where I see the laser, let's say, on an industrial level and on an R&D level helps to make it better. Of course, we we can help to, let's say, reduce the solvent in the active material, for example, using laser technology for drying of electrodes. We are structuring surface of electrodes to reduce the charging time for batteries. The laser as a joining tool, as a welding tool, allows to optimize materials. That means to reduce thicknesses of copper and aluminum, which makes the battery more lighter, because the laser is a very exact tool and allows to have, let's say, controlled weld depths in a very repeatable way to reduce spatters, to increase the resistance of a contacting area, which is very important in a battery cell. On a module level, it's the same. Also, the laser helps very much for new designs of thermal management inside of a battery module or a battery pack. And for example, in the tray design of battery packs and minimization of flanges, weld seams of lasers help here very much. If we look on the process chain of the production of lithium batteries, the laser technology has already become and is the indispensable production tool for many production steps. So let's say the red frame symbolizes in all these production steps, there are laser applications, and mainly we talk about welding, cutting, structuring, slitting, marking, and drying. And we talk about welding, and I think most applications are in the area of welding, is contacting of dissimilar materials like copper and aluminum, and aluminum with steel. And the challenge here is, let's say, make repeatable contacts and high resistance contact to increase, let's say, the quality and the resistance of the battery, and to reduce the materials. I have counted, we have over 20 laser applications along this production steps, every single production steps in this process chain. So it's quite impressive. Of course, it depends if it's a prismatic cell or a pouch cell and so on. But in many steps, without the laser is not possible anymore. And if you ask me, so where the photonics plays a major role to become greener, probably I would say we have many applications require higher quality, and lasers and sensor technology helps to reduce the amount of materials, and also the lasers help to bring production on a next level in terms of speed. Yeah. I want to feature just two technologies from our house, which we have patented. So first is we developed a green laser, and green laser, I mean, who doesn't know about laser. So we are typically industrial lasers are in the infrared spectrum, and we developed a laser which is in the green light spectrum. And green laser light is absorbed better on high reflective materials. And in the production of batteries, there's a lot of copper material which highly refracts. So we need less laser power than with the infrared laser for the welding. So it's better absorbed, and it allows us to have, without, let's say, with a lower energy use to weld the same what we would use in an infrared spectrum. And when we are in the infrared spectrum, we have the second technology, which we call bright line weld technology. That means we are using two fibers in one to have a higher density, and at the same time to, let's say, to smoothen the weld seam in a way. And that means we reduce spatters, we reduce pores, and we increase the speed. And this allows us to go with very high laser powers in a very smooth and repeatable way to weld. already at the end, but I want to highlight I think we all know the battery market is mainly driven by China, and what makes China so different for the rest of the world. And for me, I would say China is an extremely dynamic market, and it's not oriented to the actual demand for lithium batteries. So we see Chinese customers are extremely dynamic, and they are, let's say, they invest whenever they think it's not the time to invest, and they are not really connected to the, let's say, the official demand of this. There are a few but very potential players. They're very price driven. And we know that, let's say, more than half of the world's potential comes from China. So I think it's a very interesting market for us. This was a very quick run through this.
It was a fantastic run through this, Johannes. Thank you so much for being at this meeting. It is great to have you here. But you know what? This morning I got up thinking I'm going to make TRUMPF, a very green and fantastic company, even greener. You know, this is the challenge I got up with in the morning. So I'm going to try to do this. And before that, I'm going to show you something which very likely you already know. At least some of your colleagues already know because they've been very involved on Photonics 21. The Photonics 21, which is the public-private partnership with the European Commission in the Program Horizon Europe, actually is announcing a call for collaborations to write proposals for projects that will be funded between 5 to 7 million euros about laser-based technologies for green manufacturing. And the deadline for submission is the 15th of July, 2021, the middle of the summer. Thank you very much, European Commission. So one thing that is fantastic here is that they are looking at really machine tools involving various laser technologies, so milling, tuning, grinding, laser surface structuring, beamforming, additive manufacturing. They are looking at machine tools, really workstation tools, really the products of TRUMPF that could save energy consumption. And that, for me, one thing that when you look at this call, and if anybody is interested in the text, I can send it to you. It's in the website of the European Commission, but I can just send it by email. But one thing for me is very interesting on this call for European projects is they really, for the first time, they are linking the energy consumption to really photonic technologies. And they are talking about how to save energy by using more efficient optical fibers, by using programmable beam shaping or beam steering, by using a rapid quantitative feedback. The idea is to link photonics to green energy savings. And for this call, I really think that we have some of the key potential role partners in the room. When I posted this in the chat, we've been working on this call already for a couple of years. When I posted this in the chat, the Maurizio Gatiglio rapidly said, I want to say something here. Maurizio, what's on your mind?
With pleasure, Jose.
By the way, for those who don't know Maurizio Gatiglio, he requires no introduction, but I will give him one. He used to be the president of the Prima Group and Convergent Photonics. Maurizio was also in the board of EPIC for a few years. It was such an honor to have you in the board, Maurizio. Tell me, what's on your mind?
Okay, thanks a lot, Jose. So nowadays I'm just working as a freelance, but as you said, I have 35 years of experience in laser technology. And also I cover the role of EPIC director of the board, but meanwhile, I'm also chairman of the Future Technology platform. So just a few words about this call. Well, this call is included in the so-called work program. The work program includes all the call which will be presented by the Commission in 2021-2022. Let's say that the deadline is not so sure yet, because officially this document should become official for 15 April, but it is possible or likely that there will be some delays. So maybe we will have some another extra months to prepare the call. There are, as you said, 26 million on this joint call made in Europe and Photonics 21. What is important is that each project should have a budget in the range of 5 to 7 million, with a TRL from 3, 4 to 6. So let's say not too close to the end of the process to a product, but not basic research. It's applied research. In each project, there should be included 3 use cases. So we are looking at consortium which are quite large, including different areas. So we can have photovoltaic, we can have wind, we can have batteries in the same project. By the way, I'm working in building up a consortium. So if you are interested to join this laser for green manufacturing and you don't have any other contacts, feel free to send me an email. Jose and Francesca will provide you, and in the participants there is my email address. So feel free to if you have an idea to try to enter.
Oh my God, Maurizio, you don't know what you just said. Be prepared to answer a lot of emails, because we already heard many companies, many members of EPIC contacting us asking if there are anything going on this. One thing that for me, when I read the call, was very interesting, especially to link into Johannes, is really the push for beam shaping, programmable beam shaping, and the use of high power optical fibers. Do you have some ideas on what is the role of this for energy savings?
I think there is not a lot to do for an energy saving. You know, this call is one of the first call which have been done. Oh, sorry, apologize.
Not a problem, Maurizio. We are all working from home.
Yeah, sorry. No, because this is one of the first call of the new program. So is, let me say, a very political call. So I have also heard some people which were very critical about the text. There is all in. There is also an important part of data analysis, of AI, of monitoring, which I think is quite important. So it's enough generic, although the goal of the call is very clear. So we are speaking about lasers for green manufacturing. So I think that most of the people can understand clearly what they mean.
I have a lot of things that I want to discuss about this call. First, I want to go, Johannes, I'm coming back to you, but I want to go to Ruth Huberts from ThinkMate, ex-CEO of Multiphoton. We had from the European Commission many requests for very accurate beam shaping in the past, laser optics for beam shaping, but this is the first time that we hear sub-micrometer resolution. When it comes to laser optics for sub-micrometer resolution, I think there are very few people who have the experience that Ruth Huberts has had. How would you recommend when companies like TRUMPF or Prima or IPG, also present in the room and coming to Michael later, how would you recommend that they address the market of making machines, laser machines with sub-micrometer resolution beam shaping? Ruth.
Hey there. So how would they address that? So with my former company, Multiphoton Optics, we addressed that on a, let's say, more nano to micro scale. So what I think what should be combined is to combine, right? That is correct. But this comes with the surface itself. So it's definitely a optical surface, even if you do surface structuring. And it should be combined with classical manufacturing technologies like 3D printing and also others. So I would be really very interested to join and to put in my expertise in structured surfaces, and particularly in the area of energy creation. That will be really fun, because that closes the loop to my former company and to my former employer Fraunhofer. So
for me, there is I don't think there is anybody in the whole European industry who had the expertise that you have in making equipment for the additive manufacturing of submicrometer resolution structures. Nobody has your expertise, so I would think that obviously it comes to you. But as you said very well, when it comes to this, when it comes to beam shaping, the surface has a lot to do about it. So I want to go back to NIT. I want to back to Martin de Tertre, the company NIT. You have been addressing process-based manufacturing for additive manufacturing processes and also advanced laser industry. How do you see this, the need for the first time by the Commission on having sub-micrometer resolution, beam shaping and beam monitoring?
I don't know if I can help you, Jose. For your question, I'm not sure we are expertise for that.
Laser beam monitoring has been in the SWIR application field. Laser beam monitoring is one of your main added value. What could you offer to a company like TRUMPF, IPG, or Prima?
So we offer cameras with very high dynamic range. So it could be interesting for such market when you have high illumination. So this is one thing we are doing, and also we offer a shortwave infrared camera that are used for laser beam profiling. So this is what I can say.
Back to Johannes. Thanks a lot, Martin. Back to Johannes. It was a fantastic presentation. You talk about the lithium batteries. You also said that it could be applicable to hydrogen. I want to come back to this European call, which I am sure that TRUMPF has to be part of it somehow. On this European call, for the first time also, after many years, they've been talking about saving energy welding by linking different spectral ranges. Johannes, in the field of welding for batteries, as you were presenting before, do you have any ideas or anything that could lead towards energy savings in the final machine?
I lost you for a second, Jose. I hope I got you
energy
right. Can
savings,
you repeat the
laser
last?
welding. How can you save some energy in laser welding?
Yeah, first, like I said, for example, I showed you the green laser, which is a laser with let's say a better absorption on brilliant materials. So you need less laser power to do the same compared to an infrared laser. Yeah, for example, for welding of copper, we are using a laser in another light spectrum, which is better absorbed in copper. So there's a energy saving because you need just less laser power to do the same.
Yeah.
For example. Yeah.
All right, so now I'm going to go to one company that we all know and like, IPG Photonics. Michael Lee is here and he's not missing any of our laser-related meeting. Even today is a bit laser-oriented, but Michael wanted to be here. IPG is a large company, market leader in many of the laser-based manufacturing sectors. When you see a call like this one, they really want to link the energy with the photonics technology. I agree with Mauricio, there's been a lot of political and very, very fun debates. I wish I could have recorded them with this call. Anything that could, spot some interest from IPG or make greener laser-based manufacturing?
Thank you, Jose. So our idea is a little bit different from what we heard so far. So when you talk about efficient laser sources, you're not far away from the infrared fiber lasers. And I don't agree with my predecessor here about the green lasers because they have a benefit in the first few milliseconds in the welding process. Then if you open up a keyhole with a very efficient, by an order of magnitude, more efficient fiber infrared laser, you have the greenest laser source what you can use. And obviously the output is not green, but this is the greenest laser source.
You're going to kill me, and I think many EPIC members are going to want to kill me too. But isn't it already everything invented when it comes to fibers for fiber laser? We've been researching already for 20 years. We have chalcogenide, fluorescence. We have every type of specialty fiber manufacturer pool. Is there any room to cover there for specialty fiber?
I mean, on the efficiency, we are working constantly. So the package size is going smaller. The efficiency, the wall plug efficiency is going up. So we as IPG, we are at a level of close to 50% when it comes to welding lasers, from the electrical energy you put in and optical power you get out. And I would like to see this calculation for a green laser with 1 kilowatt that is way less efficient. And so you should not use this type of technology.
Back to Maurizio. Maurizio, a lot of people really wanted to have data in this call. That was one of the most difficult things, to be in the data part. You are building a consortium on this. So which kind of data companies and which kind of data challenges you want? The idea is to have real-time process monitoring, and they were talking about big data as well for a time. What is the ideal partner that could cover that particular role?
Probably a partner which is quite skilled in big data management. So basically the need that I have understood are in batteries are first about the traceability. So you have to guarantee that you know how you welded that particular battery with that particular serial number, because if in 3 years you will have your car which will be down due to problems on the battery, you should be able to trace all the data of the welding that you used, or in case of cutting of foils, or all the laser process, you have to keep track of all the data. So and it's not just enough to keep track of just 2 levels and to say, well, the weld was within the fine layers. You have to keep track of all the lengths of the weld with a certain sampling time. So immediately you generate a lot of data, and you need, and from this data you can store them just for tracking in the future, but more important, you should be able to have a sort of feedback or quality control on those data. So
thank you very much, Maurizio. Just one final comment for all of you, everybody here in YouTube. The call, as Maurizio said, on the 1st of February was already provided as a, I don't know, very mature draft. The call will be formally announced on the 15th of April. There is a little bit on almost everything: environmental monitoring, the address societal challenges. If anyone wants to be part of Maurizio's consortium, please feel free to send us an email. I will introduce you. If anyone is preparing another consortium, would like partners, contact Francesca Moglia, and she will do her very, very best to find a potential partnership here. I do think this is a great opportunity for our industry, and I acknowledge the amazing work that our colleagues have put for the last 2 years. I think now we have now the room for cooperation. Let's go back to one of the most amazing things I have seen in the photonics industry for the solar market. We're going to go to one very, very innovative company, Nice Visions, and its founder, Igor Zacek, is here to illuminate us, or actually much better, to provide us with solar windows. Igor, thank you very much for being with us today. Tell us how we can make Nice Visions a very cool company even cooler. The floor and the attention of everyone goes to you.
Jose, thank you very much for a lovely introduction. And well, it's very hard to start. I believe I will follow up a bit on Parag's presentation, or at least partially, but let me share my presentation. We can jump into it. So you probably can see my presence right now, right?
Crystal clear.
Perfect. So once again, hi, I am Igor Zacek. I'm CEO and founder of Nice Visions. It's a company from Slovakia, Bratislava. And we have started as an architectural studio, but slowly through different projects, we have transformed to, well, we call it creative technology company, or company with creative approach to renewable energy. We are currently focusing on integration of renewable energy to the architecture and urban environment. And in our line of work, we are essentially building on our architectural expertise or technical knowledge, which we build on the project showcased here. And we are trying to develop products which fits well to the urban environment. And essentially, we are our business is built on 2 verticals. One is product development, and another one is environmental consulting. So if you need some advice regarding how to approach some renewable technology, especially in urban context or architectural context, we are best guys to go. And as our motto is building a better world, we are looking at the places where it matters the most. And currently, cities are consuming over 2/3 of world's energy and account for more than 70% of global CO2 emissions. Therefore, we are looking at the ways how to add renewable energy sources close to the point of consumption, which in this case means cities. And to achieving this, it would be a very critical step in achieving sustainable future. And this is the point where I'm following on Parag's presentation. Contemporary renewable energy sources are amazing devices. They are cheap, efficient, scalable, but as you can see, they are very hard to be installed or integrated into our cities. They're really ruining the appearance. And if you take into consideration that majority of, well, especially European cities are really old and they have their characteristic looks, which needs to be present, then this really boils down to the question, how much of our existing of quality life are we prepared to sacrifice to achieve sustainable future? And we in Nice Visions believe that it's not kind of like how much quality we need to sacrifice. This is a design challenge. It is a question how well we can hide and how well we can integrate renewable energy sources into the architecture. And our step in this endeavor is product solar tiles. We have developed this as a fully integrated building envelope system, which means it's a facade and roof system. So essentially covering whole building without any leftovers. And it's specially designed for the areas where looks is equally important as energy production. Sorry. As you can see, this product merges aesthetics of Portuguese ceramic tiles with energy production of solar panels, which in this case, it makes it really fitting into the areas like historical center of Lisbon or whole Iberian Peninsula. But really, in this case, we are focusing on historical centers where the legal context is that you are not essentially allowed to install any solar panels at all. This system is based on modular grid 15 by 15 centimeters, which is combining digital print, digital print, and thanks to this modular approach and essentially freedom to deliver any pattern on any colors, we are able to deliver a wide range of colors, shapes, and sizes, and of course the power outputs. What is interesting here is that application of this kind of modules is way different than traditional solar modules, as Parag was mentioning. This is really, we are really looking at the use cases where no other solar modules will be installed. And also there is quite interesting dichotomy in a way that traditional solar modules are scalable and built along the already established manufacturing processes. And with urban applications of the solar modules, we really need to come with the methods how we can add customizability into this process, or customization into this process, which adds another layer of complexity without increasing price that much. Otherwise, there won't be any sensible return on investment on this. Well, but as I mentioned before, we are these solar tiles are the first step. Our end vision is to create solar module which is indistinguishable from any other building material. Imagine this kind of brick wall and producing electric energy. And as Jose mentioned, we are developing solar windows, which are also stepping in the way, but unfortunately, due to legal reason, I cannot show you in this presentation. But our ultimate goal is to mask energy production in a way that normal city user won't be aware that energy production is happening. Therefore, we are looking for partners, let's say research institutions, technology companies, or who are developing technology or products which can help us into endeavor, maybe photonics lab, glass vendor, coating suppliers. But most importantly, we are looking for partners who are sharing our vision of creating better and sustainable future. And maybe most importantly, what we are bringing to the table. So we are bringing in years of experience in architecture and construction industry, great knowledge of building integration and all the regulatory aspects of BIPV integration. Then also we are bringing in ability to build custom software, optical simulation in-house. And on the top of that, we are chipping in with knowledge of PV supply chain and PV manufacturing. So if you are interested, you can reach me on this email or just contact me via Jose, and we can start discussion on where should we go. So thank you very much, guys, for your attention, and I'm all yours for questions. Cheers.
Thanks a lot, Igor. Thanks a lot. I mean, we have the chat on fire also for among our colleagues. So this is something really exciting that you are doing, and we are we would be really glad to help you from the photonics side to let's say be more efficient and also still not losing the efficiency of solar cells, but still having a nice and a design-based product. So do you have maybe something that is more like where is it the area that is actually in photonics help that you see that you can have more help? So it's more in the production and integration, or it's more in afterwards when, for example, maintenance of the walls. If you can reduce maybe the maintenance because then once they are put there, you cannot do much. So they say maybe they have to stay clean, the surfaces. This is something that
yes.
you can do with lasers, for example.
Yeah, my call was really formulated as very broad, but we can start maybe from the end. So installation. So it would be great to reduce fouling of a solar module. So the question how to ensure that they are cleaner longer, because city it's quite dusty environment and not very well. We are really talking about non-optimal use of a solar modules, and there are so many questions how to change this non-optimal situation to make it at least a bit better. So coatings, we need maybe process changes in a way, like for example, if we are talking about front glass manufacturing, usually you have just one size which is optimized for a majority of solar modules. But if we are talking about application within the buildings, you have two windows and suddenly you have 45 centimeters and you need to put their solar panel. Suddenly you either produce a very expensive one or you try to figure it differently. So it's really open. Then we are also talking about cabling, because if one MC4 connector costs €6, then suddenly if you have a lot of very small connectors, very small modules on the building, then suddenly price of the whole installation rise astronomically, and regional investment goes out the window. So that it's plenty of questions. So if you feel that you have something which can increase efficiency, lower the price, increase longevity, help us to increase the manufacturing process better, then please reach to me.
Then I see that Ruth has an idea. So maybe Ruth, you can maybe already say something about it. So how to combine technology with other things about buildings. So
I could, but I will not. You know why? because I think it could be patented first. So I will think about it, and yeah, if there is interest, I'd like to share that, but not here. Thanks.
Okay, good. But then Igor knows now. She had a statement. It's something very cool. Otherwise, she would say it if she's not so sure that is a good idea. So Igor and Ruth, if you don't get to talk to each other by exchanging email address, we will do it for you. So
yeah, that would be great to have at least small chat.
Yeah,
very informal with limits on IP.
Yeah, okay. So Jose has a comment, so please.
I always have comments, and I want Michael Lee to talk afterwards, but I always have comments. And in this case, I want to talk to Ivan Davis from IQE. Igor, in private, we had a lot of discussions a few months ago, and I love what you're doing. I really love what you're doing. To what extent do you need customization of the solar cells, or can you actually use off-the-shelf material?
For now, we are using off-the-shelf products, but for example, for solar windows, when thickness is very thin, that definitely needs to be something which is customized, because there are very little manufacturers who are supplying very long and very narrow solar cells. So yeah.
That's why I brought you to this meeting for you to meet my friends. And I have a very good friend at IQE, Ivan Davis, looking great. Thank you very much for joining today, Ivan. Ivan, how does this resonate with you? I know that the solar line of IQE is still very active. The VCSEL as well, I know as well, but the solar is very active. How do you see the customization of solar cells? What kind of volumes are interested for IQE on this?
Oh, again, traditionally we've been involved with, concentrated photovoltaics, which are very expensive but very high efficiency. And I suspect that there's still a future for those, but they are, given that they are so expensive, we are starting to look at, applications where we're transferring them to cheaper substrates and reusing the material as the substrate material, for example. So we're starting to look at transferring the epi layer, if you like, lifting off the epi layer onto a very cheap and very thin, lightweight substrate, because that's the only way I think we can get some lowering of the cost, for example, but albeit at a high efficiency. So, I don't think we're possibly talking about the same type of solar cell that Igor has been talking about in buildings and, in built-in PV in buildings and building materials and glass and the fabric of buildings. I've come across those in various various seminars in the past, but our technology is mainly focused primarily on space. And high altitude, for example, is another where we can coat the wings of aircraft or unmanned aircraft, for example. So, whether we can sort of transfer that technology to buildings or
Igor has very well defined specs, which I would like you to have an offline, private, maybe NDA-based discussion, because I think, Ivan, you're going to be surprised. But I would like to, first of all, thank Igor for the amazing presentation. I got goosebumps. I can't say how much I love what you're doing. I want to go to Michael Lee. For two reasons. The first one is because you made one of the most exciting chats about the green industry. And the second one is because you have a question, I believe, for Parag from EuPD Research about the photovoltaics EU Renaissance. Michael, first ask about the photovoltaic, and then we go green laser. Michael.
Yes, thank you,
What
Jose.
is your question for Parag?
Yes, my question is right now, as we see the PV renaissance on the European continent again, and I was heavily involved in all the downturn 10 years ago when this industry somehow imploded. Yeah. I would like to see, what do we need at the photonics industry to help the PV integrators, the PV industry, to establish more reliable business on the continent again?
Well, I mean, I think you mentioned, and this point is absolutely correct. This also relates to Clark's question of how do we see manufacturing in the European continent vis-a-vis China. You're absolutely right. So there are companies such as Meyer Burger, which are trying to set up production capacities within Germany. And this is something which is happening, but with the HAT technology, the efficiency is higher. They have a particular segment in their mind, which I can completely understand, where they are planning to produce high efficiency cells. And for them, the utility scale market is not going to be the major market. It's going to be the residential segment, very European focused. That's probably a good start because within Europe, we have a very large distributed market. So for them, this is going to be the segment that they will be targeting. Definitely, we are seeing a huge growth in this distributed segment. So that I clearly can understand, that's the segment that they would continue targeting. Edge AT, definitely that one. Also, you have many other manufacturers. I think somebody just sort of hinted REC is following the same. So they are also planning to produce their solar panels. They currently have a production capacity in Singapore, again, a high cost place to manufacture solar modules. So this is a trend which we are seeing, and it's kind of lowering the dependence on China. But this is, again, depending on the niche that they are working on. So
thank you very much, Parag. I would like to say here that, of course, for all the EPIC members, we do have a contact in the solar industry. Hanwha Q Cells has a European-based pilot line in Germany, and they have done a lot of innovation with many of our members. So you have a technology, laser technology or material technology, and you want to go into see if it can fit the pilot production of Q Cells in Germany, contact EPIC and we'll make that introduction. Michael, you posted a lot of very interesting things about green lasers in the chat. I don't know if you want me to read them because we are in YouTube as well, but I could just say that you do have some interest and some ideas here. Share with us, green versus no green.
Yes, I mean, both technologies are around for many years now. So, and the customer has to value and let's say counting on results. This is all what I would like to say without finger pointing here on somebody else. To my understanding, give the near infrared lasers, let's say with the leading, efficiency, with the leading power rates per beam quality value a chance. And then you can count on the results. That is all what I can say.
Count on the results. So this is a lot that you can say. I would like to ask you something else. So IPG is a very vertically integrated company, very vertically integrated, developing their own solutions from the components all the way to the systems. So I need to ask you this: when it comes to this technology, is there any room for cooperation, any challenge that you would like to share with the rest of the participants to help IPG, a great company, be even greater?
I understand that many people want to help us out because we are attractive corporation to work with as a supplier. We are so huge, vertically integrated that it will be hard to find some, let's say, spaces to move in. Basically, we are open to talk. So drop me an email. I would love to share that with the EPIC network and link to the EPIC network. But we should make it offline, I would say.
So I would like to say here, for everyone who thinks, as I just said, that IPG is vertically integrated, I introduced Michael Lee, since he's in our network, I introduced him to about, I think, 8 to 10 companies. He followed up with each and one of them. With each and one of them had a discussion about the potential cooperation. For that, Michael, thank you so much. Maurizio Gattiglio, near infrared and green are not the only solutions. Something about blue. What's on your mind?
Oh, well, clearly there have been in the chat some statement about what is the best because clearly the absorption of copper and aluminum for the green wavelength is much better than pure infrared. But we also know that after the start of the process, if it's a keyhole, this effect is a little bit reduced. Then clearly, I don't want to do here just a conference on that. I was just saying, don't forget blue lasers, because the 450 nanometers wavelengths of blue lasers is very near to green. One of the points which was raised in the chat was, well, green lasers are expensive. Those are green lasers from fiber. You need for polarization maintaining active fiber. This is quite complex. It's a little bit easier if you use a disc laser, but a disc laser is more costly technology. Blue laser is a simple technology. It comes for the blue diodes, so it's potentially cheap. On the other side, cannot have the same brilliance of infrared fiber lasers and disc lasers. So it's an interesting challenge, I think, and we will see in the next year who will be winning and for which application. There not will be probably just one solution for everything.
The blue laser diode had a fantastic year last year. Lidars, which is now coherent, will soon be something else, had a really great year. Also BWT as well. The blue laser diodes is really, really booming. I would like to move on, but this was one of the most exciting chat discussions. So thank you very much, Michael, for this. We continue with the program and we go to one of my favorite cities in the whole universe. In part, in Europe, we have Glasgow. In Europe, we have Glasgow, Fraunhofer, CAP, Fraunhofer UK. David Armstrong, thank you very much for being with us this beautiful afternoon. It is 4:34 here in the Netherlands. It is 3:34 in Glasgow, in the European continent. The floor and the attention of everyone goes to you.
Afternoon. Thank you. Thank you for the introduction, and thank you, EPIC, for a really interesting afternoon. So I'm David Armstrong from Fraunhofer Centre for Applied Photonics, and here's our building in Glasgow city centre on the University of Strathclyde campus. So just a brief introduction. You know, we're part of the Fraunhofer Gesellschaft. We're a Fraunhofer like lots of institutes in Germany, but we're a UK research and technology organisation, an RTO. And our competence is in applied photonics. So what does that mean? Well, yes, we can develop laser sources, lots of different architectures, wavelengths, characteristics. That's something that we're very comfortable with and accustomed to. But increasingly, systems, instrumentation, using the laser light to answer questions, to detect a substance, to do standoff imaging or detection in some way. So that's our business, if you like, and we work with industry. We're a collaborative, as you'd expect, with a Fraunhofer, a collaborative organisation. We don't commercialise ourselves, so we really are there to help industry. So, in terms of this topic, there's really two things I want to talk about very quickly. One is work on hydrogen sensing, which is interesting, quite a current area of activity, and one is subsea cable monitoring. But I'll start with hydrogen. And now, I think unless you've been, living under a rock, you know that hydrogen is going to be a big part of the energy mix in the future. And one of the challenges we were set was to monitor hydrogen emissions. And so, why would you want to monitor hydrogen? Well, that might help you monitor a process. It might help you account for the emission of hydrogen in a large scale that you might have to account for. Hydrogen is actually an indirect greenhouse gas. It's more complicated it's more chemistry than I can remember or understand, but it's involved in greenhouse processes in the Earth's upper atmosphere. And also you might want to know this for safety reasons. Now, usually standoff detection of say a hydrocarbon using photonic techniques, you might use infrared absorption in maybe the mid-IR, certain wavelengths, to do standoff detection imaging of hydrocarbon leaks. The problem with hydrogen is it doesn't really possess a strong absorption characteristic in infrared. However, the good news is that it does have a relatively strong Raman scattering cross-section if you interrogate it in the UV, ultraviolet. So yes, you can buy electrochemical sensors for hydrogen and they give you the local concentration, but what if you want to know what the hydrogen concentration is 100 meters away, or you want to scan a seam? And this was the challenge that was given to us by the UK nuclear industry. So Sellafield, which is a large facility in the UK, and the National Nuclear Laboratory, they are storing nuclear waste. Maybe you can argue nuclear energy is part of the green solution as well. They're storing nuclear waste in 3-meter cubes. And it turns out nuclear waste gives off hydrogen. So they wanted to monitor the hydrogen emission from these cubes. But it's good. obviously applications in the wider hydrogen economy. So we put together a system. This is an ultraviolet laser, giving pulses of ultraviolet light. And we're basically doing LiDAR, a bit like radar with light. So we're detecting very low levels of the Raman scatter coming back to us from the if you like, the cloud of hydrogen, using quantum devices, very sensitive single photon detectors. And we can detect indeed 0.1% concentrations of hydrogen at 100 meters or so. An important thing as well is we can see through, if you like, higher concentrations of hydrogen. And the picture here is a system that we deployed in a nuclear facility not so long ago. So there are lots of opportunities here in terms of collaborations and developing this technology further, miniaturization, maybe closer range measurements and so on. So that's something that we're keen to pursue. So that's one part of our work. And very briefly, another area that the photonics techniques can impact is the renewable infrastructure, renewable energy infrastructure. It turns out that if you build offshore wind turbines, you have power cables leading to the mainland. And it turns out these power cables are extremely vulnerable part of the infrastructure. And they account for a big problem in insurance claims. For example, if the cable, the undersea, the seabed is worn away underneath the cable and the cable moves and causes a problem. So very briefly, we've been involved in projects in using the optical fiber inside the cable to monitor the cable, whether it's moving, its temperature, for example, distributed along the length of the cable. That's an active area of research for us. Projects in Orkney, the European Renewable Energy Centre there, detecting, for example, even the tidal motion in the sea there. So I'll finish very briefly. We're open for European Union projects in this area. And just briefly, this is a picture of one of our wind LiDAR systems installed and operating in the North Sea, which is maybe a hint for the next presenter. So I'll leave it there.
Thanks a lot, David, for your contribution. So as usual, I mean, you mentioned in the end a bit that you are open for collaborations, but you know, the EPIC questions is always a bit more specific. What can you do for them? What can they do for you? So maybe you can see you have, as you've shown already, a lot of different expertise that can be placed in different area of grid energy production and monitoring and maintenance. So where do you see maybe with the audience here today possible collaboration? So how the audience can support you, or the Photonics anyway in general, so our 650 plus members can help you in collaboration or in application also for funding together, in which topics exactly?
Well, I was interested in some of the photovoltaics. Is not an area that we consider ourselves to be experts in, but certainly, if you like, the making monitoring devices or instrumentation to monitor PV cells perhaps is an area of interest for us. Certainly something we've developed to high TRL. So that's one thing that I learned today. Is my takeaway is that area for sure. There are a number of laser companies online today. You know, we develop. You know, I'm offering, if you like, what we can do is developing of new laser technology, new wavelengths, new characteristics for commercialization elsewhere. That's an area, something we can offer. And if you like, the request is just in general is that we're very keen to participate in European Union projects, particularly the wider, if you like, hydrogen economy is something we're interested in to see.
Very good. So now this stays on stones, maybe not on stones, but on YouTube also. So please, everybody is listening here in the room or also on YouTube today or maybe tomorrow or later on.
Brexit questions allowed at EPIC meetings. I would like to very much highlight that. David, we have discussed with many different partners about collaborations with quantum technologies, and on that you have been quite outstanding on bringing end user needs. It's quite public, your collaboration with Thales UK, for example, end user needs to this technology. When it comes to the green world, the green ideas, we talk already, we had some visions here, but is there any like top of your head priority for Fraunhofer UK to enter a EU project? I know you have been very, very interested in joining European projects. Is there, what would be the number one challenge for the upcoming ones?
I would say is hydrogen and the hydrogen economy, I would have to say. That's a big, exciting area. Europe has, well, the UK, for example, has the capability of generating renewable energy through wind, for example, and there's also increasing work on co-generation of hydrogen with nuclear as well, and small nuclear.
Hydrogen fuel cells are the driver of the future world. I'm 100% sure about that. Maurizio, in many other meetings, we discussed about the need for welding of hydrogen solar cells, which is a specific need to the one that lithium batteries have. Is there any people in the top of your mind, any companies who are excelling on this? I know SPI Lasers is quite doing some work on that. Who do you think should be the ideal partners to address the welding of hydrogen fuel cells?
Clearly, if you want to build up a consortium, you need to have some lasers manufacturing in, some system manufacturing in, some end users even more important in. So this is the way how you have to build a consortium. Then you have also to represent well, considering these are European projects, a geographical distribution. So I'm going to say there is not an ideal partner. There are many potential partners. The important thing is to build up the consortium with a fil rouge in mind, and covering all the different competencies and skills which are needed, from lasers, photonics, very important, to system integrators and to end users.
So for us, building a consortium is something that, as you know, we do twice a week, and I am extremely happy with this. And the end users, of course, the most important part here. One thing that I would like to ask for all the universe, everybody who's watching this, could contact me if they know about the needs for beam shaping, for welding of fuel cells. If you have some information about this, people in the room, but also people in the YouTube universe, please send me an email, WhatsApp, anything. I really want to talk about this. I have some very specific questions I cannot share. I want to know what is the beam shaping needs for hydrogen fuel cells. Back to Dr. Moglia. Once again, congratulations. What an amazing job you've done today.
Thanks a lot, Jose. So now that, as also already David was concluding a bit more towards the wind energy, maybe it's now time to call Manuel on the floor.
Hello.
From Zacek Lidars. Yes, we hear you very well. So maybe it's now time to speak a bit more about LiDAR and the experiences of ZX LiDAR. So the floor and the attention of everyone goes to you. There it is coming.
Yes, hello. Can you see my screen? Yeah, can you see the
something is coming?
Yeah, it's a bit slow.
Yeah, it's a bit slow. Let's see, because we don't see it.
Really, but I'm sharing.
Yeah, I know, but it's the typical bandwidth issue when maybe you don't.
And it's just a PDF.
Okay, yeah, but then you shouldn't, right? Because before we saw it. So let's. Okay, now it's there. Talking. Now it's there.
Okay.
There you go.
Thank you for the invitation. All right, thanks for the invitation to EPIC. Good afternoon. My name is Manuel Queißer from ZX Lidars. Sorry about any background noise because I'm not alone in the office. So ZX Lidars, previously known as Zephyr Lidar. We are located in a converted farm here in the beautiful countryside of West England near Malvern, UK. But you can say that our stage is the world. Why? Because we deliver a key tool for decarbonizing the world's energy generation. We are a leading R&D-based company that develops and builds wind LiDAR systems, and which has pioneered the use of wind LiDAR for commercial applications, in fact. Our R&D legacy goes back to the days when the laser was invented and the LiDAR was invented, both in the 1960s. Compared with traditional measurements of wind using meteorological masts, a wind LiDAR gives you more accurate and much cheaper data. And that's why our wind LiDARs are now used for accurate and precise measurement of wind speed profiles, both on and offshore. And this forms the basis of wind resource assessment in the wind industry. And that's why you can say that wind LiDAR contributes to making wind energy significantly cheaper and hence more widespread. And this is kind of in line with what Parag said in the beginning. Green energy gets cheaper and cheaper, and wind LiDAR plays a significant part in this, especially for offshore wind energy. And you can imagine that wind LiDAR may help to decrease greenhouse gas emissions in many other exciting sectors as well. Just to mention one example, our LiDARs play a role in the renaissance of large sailing freight ships, where they are used to measure the free stream wind that is approaching the sails. This is just to give you one example. What is the wind LiDAR actually? So wind LiDAR is a subcategory of LiDAR, an optical remote sensing technique to measure wind speed and direction. And our LiDARs use the well-known Doppler effect for that. Aerosols such as dust or pollen, they move with the wind streamlines, and hence their movement gives us a very accurate picture of the wind vector field. And now the LiDAR measures the shift in the optical frequency of photons backscattered by these aerosols. And this frequency shift is linear proportional to the aerosol velocity. And the frequency shift is then measured by a very sensitive detection method called optical coherent detection, where the emitted photons interfere with the received backscattered photons. All right, so here are our wind LiDARs. We have the ground-based wind LiDAR, a marine version of it, and a turbine-mounted version. Why turbine-mounted? Well, a more recent trend is to not only use wind LiDAR to measure for site assessment, to measure vertical wind profiles, but also to integrate wind LiDAR as a sensor in the wind turbine itself, which allows to increase the energy yield and also the lifetime of the turbine. And you can imagine that with about 25,000 new wind turbines erected every year, the potential there is quite enormous. And let's skip to the next slide, by the way. Turbine-mounted wind LiDAR is coming of age in a few days, celebrating its 18th anniversary. So that's quite a coincidence. And I come now to our wish list. What can the photonics industry do for us? A general comment, our LiDARs operate 24/7, pretty much all over the world, and under often very challenging climatic conditions. So reliability is key. And well, a central component of the wind LiDAR is the laser. So we are interested in lasers, of course. Our LiDARs also use cold-emitting optics, such as lenses and optoelectronics, which offer diffraction-limited performance and have to run for years non-stop. So if you have a deformable 3-inch lens, then please do let us know. The same goes for beam steering optics and optoelectronics. And we're also interested in other optoelectronics, such as low NEP detector modules, all around the typical telecommunications wavelength. And since the laser is so central to a wind LiDAR, I would like to give a few more detailed specs about the laser. We are interested in all possible laser solutions, basically, so long as they fulfill a few key requirements, which are outlined here. As I said, climatic conditions can be tough. So, for example, occasionally a laser would need to be able to cold start at 0 degrees Celsius, even though in general, in general, the laser would be in a rather benign environment inside the shell, which you can see here. And the output power of the laser will depend, of course, on the exact laser platform. That's why the output power range here, given here, is quite large, 10 milliwatts to about a watt, TW. Yeah, and line width and RIN are also very central parameters. And this shall be it for now. Thank you very much for your attention.
Wow, thank you so much for this. I cannot believe I was telling Francesca. I was telling Francesca that the most interesting slides of the meeting today were the last two slides shown at the meeting. And thank you very much for that. Let's go to them. Let's go back to them because we need to find you. You came with a shopping list, so I need to find you people who are going to supply this. So let's go back to this one. I love it. You talk about near diffraction, limited focusing optics. So what is the challenge here? And I will go to some of the people in the public that I think can help you.
Well, I think one of the main challenges is as you increase the aperture size, it gets harder and most importantly, more costly, more expensive to manufacture. For example, a lens that gives you diffraction limited performance, and this is a challenge we are always facing. Yeah.
I have a lot of people in the room that I think can help. Before I go to the one that I think can help you the best, I'm going to leave it open. 5, 4, 3, 2, 1. Of course, Ruth Huberts. Ruth Huberts says these people are looking for very, very customized optics manufacturing, very fast, low cost prototyping, and really go to a company that can provide the first prototypes. Do you know anybody who could help them?
Yes, of course I do. You know that I know people who could do that. So the question is, when we talk about aperture and everything, we need numbers. So if you could supply a specs list, so then we can decide which company might be the best. But when it comes to miniaturized optics, light optics, high performance materials, I would really recommend that you use my former company, Multiphoton Optics.
Thank you very much.
For prototyping.
Manuel, I will make an introduction to Multiphoton. They are really, really fantastic people in Würzburg with a company with amazing presence and even most amazing future. Ruth, thank you very much for your presence in this meeting. I think there is a lot of follow-up for you. I want to go back to your laser. I want to go back to the laser requirements from Zacek Lidar. You talk about 1550, around 1550 plus minus 40 nanometers with 10 milliwatts to 1.2 watt and less than 50 kilohertz line width. What is the ideal laser? Are we talking about an array of pixels, for example, could do the job?
Well, it's really hard to say, to talk about this without saying anything confidential. But no, we're talking about narrow line width single mode lasers. So anything laser modules, for example. It's really hard to talk about this publicly, but I've put my email address there.
Yeah. So and there's many people
somebody
who
wants to take it offline.
Bandwidth 10, I'm calling for Convergent, I'm calling for well, all the companies that we have in the of course, Focuslight is telling me as well they're interested. So anybody, I will make the introduction, but you also have here the email address, manuel.queißer@zacekslidars.com. come. You come with a shopping list, we will deliver. But I would like to ask you now about your future. Nanoplast has single frequency diode lasers, and they are really fantastic. Thanks a lot, Michael Lee, for mentioning. One thing that is very interesting here is I would like to know about the future of Zacek's Lidars. In 5 years, we had this conversation again, and you give a presentation, how would Zacek's Lidars look like, and especially how would the market look like? It's going to increase in volume?
Yeah, well, I'm not. I'm just a simple-minded scientist here. I'm not the commercial director, but what I can say is that in the next 30 years, the installed offshore wind energy will just skyrocket from, I think now, I don't know the exact numbers, but it will be multiple factors higher than now. So the offshore wind energy market is expanding, and we are just at the beginning of this growth. And we ourselves, we are actually currently in a converted plant. You can see here in the background, it's quite nice. And we are soon we're going to be moving into a brand new headquarters. So that means we are expanding. We're also always looking for talented people. If I can say this is maybe something I should have put on the slide. So we
no, don't. Yeah, it's good. Your slides were perfect with the laser specifications. We're going to share for everyone. You know what, Manuel and everyone? It's almost 5 o'clock, and I had to say it has been really a great meeting. For me, I would like to highlight 5 highlights. The first one, we had this opportunity for EC funding, European Commission funding. There is a call to be announced the 15th of April, but we already have the draft. I have the draft. I think all of you have the draft. And they are looking for laser-based green manufacturing. They are really talking photonics, and this call is a great opportunity. The second one, Enel Energy is looking for photonic partners, and they were talking about specific specifications to talk with our members. So let's try to find cooperation for them, especially for the optical sensors for temperature. This is something that we are going to definitely help. TRUMPF really gave us a mega trend, the huge growth in technologies for the e-mobility. They presented the lithium batteries, but this is something that is going to grow, and we're going to have a meeting on e-mobility. Many of you know that already. I also would like to talk about nice visions. I'm amazed of what they want to do and what they can already do. And they're looking for partnerships, and the future is really solar bricks, solar windows. It's so amazing what they are managing to achieve. And finally, we had an amazing presentation from Zacek's Lidars. They came with a shopping list, and mostly they are looking for low-cost narrow line with lasers and near diffraction limit focusing optics. All of this in 2 hours. Lots of potential cooperations in 2 hours. I would like to say that many of you think that the meeting is over. The meeting is never over. The meeting finishes now, but we continue with the follow-ups. If you have a technology that can answer the needs of any of the participants today, please make sure you do a follow-up. These people are super nice, and they are looking forward to do cooperation. If you want to get in touch with any of the participants today, just drop me a line, jose.pozo@epic-azo.com, and I will be more than happy for making the introduction. I would like to already say as well that we have the topics for April and May. They are soon to be in the website today, and you're going to be quite amazed that we continue bringing all the companies together. We're addressing, for example, on Wednesday, co-packaged optics with Facebook, with Google, with Amazon, where we also have technologies like laser optics all the way to urology, everything to bring the companies together. On behalf of medical experts, photonics experts, laser technology experts, quantum experts, the innovation manager Antonio Raspa, the CEO, many of you know him, Carlos Lee, and a fantastic team of people. Take care of each other. Wash your hands, wear a mask. Soon we're going to be traveling again. Until the next time, see you later. Bye-bye.